Hello and welcome to Game Revolutions, the series where I take a game I started writing in high school and work on it some more now. Why? Because in the intervening decades, I couldn't come up with anything better to do. In the past couple episodes, we added the ability for the card to shoot, and we added some rocks to shoot at. But there is no code that detects whether the bullet hit the rock. We need to add some hit detection. And while we're at it, let's make the rock explode. Well, guys, I think we've got a real explosive hit on our hands. This is my first take on hit detection. The idea is that there's no fancy explosions or anything. I just need to know if the code knows that the bullet hit a rock. And the way I'm going to know is that the code will remove the bullet when it hits the rock. That's it. The rock is still going to stay around. There won't be any explosions or scoring or anything. Bullet just disappears. And I'm doing the hit detection inside the bullet routine. So this is the routine that adds new bullets if the button is pressed, that erases the old positions of the bullets and draws the new positions of the bullets. So we go down here, we blah, 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 we're going to erase the old positions, we're going to draw them in the new positions, blah, 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 blah. Here's the horizontal bullet. We're only going to do horizontal bullets right now. They're the only things that can hit the rock. And so, blah, 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 we draw it. And then here we go. Check for horizontal hits. So the first thing I do is I grab the offset of the bullet, and that is in my D register. So this is the full offset relative to the very beginning of the screen buffer. And then I do this. The remainder, when you divide the offset by 32, will be just the horizontal offset of the bullet. So if the bullet is all the way on the left-hand side of the screen, after this B will be 0. If it's all the way on the right-hand side of the screen, B will be 31. I save away the high byte of the offset, and then I begin iterating through all the obstacles. Recall the obstacles are both rocks and holes. So for each obstacle, I look at its type. If the type is not a rock, then there's nothing to do. I just skip down to the continue. And the continue is the part of the loop that does all the updates. So I advance to the next obstacle, check to see if I'm at the end, and if not, then I go back up to the top. So the interesting code happens when it is a rock. Then I compare my bullet horizontal offset with the rock offset. If the bullet's offset is less, then I skip, just like I would have skipped if it weren't a rock in the first place. Idea being, at this point, the bullet is too far to the left to have reached the rock. Otherwise, I fall through, and I then ask if the full offset of the bullet is within the vertical range of the rock. Basically, if it is higher than this screen-wise, meaning it's lower than this numerically, it's not in the range and I skip. Otherwise, if it is below this screen-wise or higher than this numerically, only then will I finally get to here. This is the code that removes the bullet, clears out the structure for the bullet, and if we just jump over there, you'll see that's all it does, is it just clears this. The type tells you whether it's horizontal, vertical, or non-existent. So clearing it will make it non-existent. We will no longer draw it. We will no longer consider it. So that's what we're looking for. Will the bullet make itself disappear if and only if it comes in contact with a rock? Since this is my first attempt, the answer is definitively no. But I don't know why it wouldn't. My code looks great. Okay. All right, so as soon as I shoot, that's when the Coco tells me everything is okay. All right, this one was not hard to find. Perhaps you already found it. As a hint, when things go incredibly wrong, like everything resets, I was probably messing around with the stack in a bad way. I was probably doing something stupid. So recall, I load D with the offset of the bullet. I save the high byte of D. Later on, I was restoring the high byte so I could do this compare, but this doesn't restore the high byte. I did a push when I meant a pull. But actually, I don't really even want to do a pull here because I want to keep this on the stack and continue to restore this every time through the loop. I really only want to balance the stack when I'm totally done with the loop. So here's what I'm going to do. This should be this. I will read whatever I pushed onto the stack back into A, thus restoring A. And then down at the end here, after I choose to loop up. Thus here I am not looping up. The loop is totally done. And then I rebalance the stack and I can just do, just do this. That's like a pull without actually pulling it to a register. That'll just adjust my S. This will keep things super balanced and everything will be great now. Okay, if I shoot here, there was nothing to make it disappear, so that's good. I have my rock. Okay. Once again, sometimes these bugs are actually better than the intended game. I don't know what this would represent in the world of Moon Patrol, but maybe I caused a moon shower of some sort. Okay, I see what the problem is. I was restoring the stack when the loop was done. Good for me. There's another way for the loop to be done, which is if it's time to remove the bullet, because I will also break out of the loop when I do that. So I need to restore the stack here too. No one should let me near a keyboard. Here we go. Regular, good. Bullet goes all the way. Nice. Rock. Yes! It disappeared when it sunk into the rock. You saw that, everybody, right? Watch. Yay! It disappeared. And nothing else crashed. All right. Shouldn't take me this long to do very little code. Next up, I'm going to make the rock disappear when it's shot, just like the bullet disappears. Turns out this should be pretty simple. So just before I balance the stack, all I need to do is grab the current obstacle I'm looking at and clear out its type field, because this is what lets us know that that structure, that obstacle structure, is not in use anymore, so we should no longer be drawing and erasing it. So on the next frame, the rock should no longer be drawn, just like I was doing with the bullet, where on the next frame the bullet would no longer be drawn. This, I think, will make it even easier for my eyes to kind of debug that it's actually been hit. All right. Oh, well, almost. It's pretty good. I'm not going to worry too much about that. It looks like the hit detection is doing the right thing. Okay. If I do rapid fire, they all get shot. Pretty cool. Okay, turns out this is not quite doing what I wanted. Watch what happens if I jump over a rock and then shoot after the rock has passed me by. So jump over, shoot, jump over, shoot. There it goes, see? It's like it, shoot, see? Shoot, as soon as I'm within vertical range, even though I'm past the rock, the bullet is past the rock, it's still, yeah. So my checks aren't complete yet. Okay, here's the problem. Let's say these are the 4 bytes of the rock, the 4 horizontal bytes. It has a width of 4. And let's say B is the offset of the bullet, which, by the way, is handy because B happens to be the register that contains the horizontal offset of the bullet. So B for bullet and also the register. All right, so the check that I was doing before compared the bullet with the obstacle's offset, and if the bullet was too far to the left, it didn't count. So I was comparing B with this. So if B is less than that, it doesn't count. If B is here, here, that counts, here, that counts, here, that counts, here. Unfortunately, if the bullet is any of these places, it counts, because none of these are to the left of the rock. So I need to add something else that says, well, if it's to the right of the rock, then it doesn't count. So the first place where that happens is right over here. And so what I'm going to do is I'm going to temporarily subtract 4 from B. So if B is here, and I subtract 4, I'll end up And so then I will end up comparing that again with the left side, but B subtracted by 4. And now, if B is greater than this, then I know that the original B is off too far to the right. In fact, maybe all I really need to do is greater than or equal to this. But it kind of doesn't matter because the car has the bullet at, at the right-hand side, so I can be off by 1 and it's not really going to matter. So I just have code like this. After I check that it's not too far to the left, I subtract 4. I then do the same comparison I did, but with the updated B. And if it's bigger, then it's too far to the right, so again I skip. And only now do I continue on with doing the vertical check. Okay. All right. Very good. And now, okay. There we go. That was a good test. That was a good test. I would like next to try to do something more fun, like explosions. In the original Moon Patrol game, the explosions were fairly simple. Mainly just a loop that expanded in radius very quickly. Back to my highly advanced sprite editor. I'm thinking something like this. So each of these X's, this would be a pixel. So imagine a loop that's this wide, and maybe I could have a loop in BASIC that redraws this, but it kind of closes up that loop. And then the sprite itself, it would animate to be in reverse order. So it would like start here small and then quickly grow up in radius. Here's the basic code I'm thinking of. We'll make 3 frames, one where J is 4, one where it's 2, and one where it's 0. For each frame, first we clear the screen. And we add 100 random dots in the area of the explosion. And then we use the value of J and J plus 1 as the ring offset. The ring offset tells me how far from the edge it's going to go. So if this represents the edge, at some point the ring offset will be 0 and we're just drawing this. But the bigger the ring offset, the closer these X's go to the center. So I transferred those coordinates from that text file into these line commands. And the subroutine just draws it all. And it will draw it twice for the 2 values of RO. And then finally, we go to 1090, which as usual pokes all the bytes of the sprite into the top of the screen area, and then save M's that part of the screen area into a file. And we'll be calling it expl. That would be first frame. Second frame. And the third frame. And when we're done, we can see that we have those expl files 1, 2, and 3. Next, we run a simple batch file to copy the explosions from the Coco disk to my PC disk. And then it's back to my Java helper bin to FCB. This time I've used the code that's customized for the explosion binaries. And down here it's expecting names like expl followed by the index. So this should generate for me 3 sets of bytes. And sure enough, here we have explosion frame 1, explosion frame 2, explosion frame 3. And here I've added the bytes to my assembly file. I have the bytes for frame 1, frame 2, and frame 3. And check this out. I've decided to treat explosions just like holes in rocks because they need to do the same thing. They need to scroll right to left with the gravel, and they need to scroll off the screen on the left-hand side. This way I get to reuse all the code that does that for holes and rocks. So I've also adjusted the obstacle info struct to contain information on where the bytes for that sprite live. So this would point, for example, to the explosion frame data, or it would point to the hole data, or it would point to the rock data. And the cool thing is that since now we're dealing with animation, whereas the holes and rocks were not animated, but the explosion is, I can keep on changing this each frame through the animation so it will automatically pick up the bytes to draw from the appropriate frame. So I used to have code that would do conditional branches to figure out how to initialize the pointers for either a rock or an explosion. Now I can just read that information directly from the obstacle info structure. Okay. Ooh! Hey! That's not so bad. That looks pretty good. Artifacts seem to be gone. Ooh. Oh, nope. That was an artifact. Darn it. How did that happen? How did I do that? No artifact. No artifact. If I'm moving. If I'm jumping. How did I get that to happen? Jumping. Oh, geez, I saw it. You saw it too, right? It wasn't just me. Something happened there. Okay, I'll do rapid fire. Oh, now I'm out of rocks. Darn it. I'll try a rapid fire. See, does that make it happen? No. Oh, yeah, there it is. And there's one too. Damn, this is kind of tough. Yeah, there it is. Hello. Mate sucked you up. Okay, what I think was happening is that I was erasing the bullet with pixels that were not supposed to permanently be there where the bullet was. They might have been pixels that came from the rock or the explosion or something. And so I was redrawing that piece of the rock or that piece of the explosion when I meant to be just erasing the bullet. So this line of code used to take the byte that was there right before I drew the bullet. It actually was this, because this is where I'm about to draw the bullet. So instead, I'm just hard coding it to be green, and then that's what I store as the original byte in the bullet draw info structure. Now this means I'm going to need to do something similar or smarter for vertical bullets. Vertical bullets don't just go through the same color space. They go through mountains, which have two colors, and the sky, which is yet a third color. So I'm going to have to figure something out when I do vertical bullets and I do explosions there. But that's future me's problem. The problem with hard to reproduce bugs is it's never obvious if you've really fixed it or not. Because it took a while to see it happen. I don't know. It looks like it's probably good. Whew, that's pretty neat. Alright, and we're out of rocks, I think. Why don't we just call it good, folks? I mean, the bullets seem to look good when they are not shooting a rock and when they are shooting a rock. I think that's a wrap on explosions. Next time we need to do the other kind of hit detection. Did my car hit a rock or did it fall into a hole? So we need to start adding some actual challenge to this game. Until then, as always, thank you for watching.